All right. So, this is the third lesson in our beginner C++ coding series, and today we're talking about loops. So, what is a loop? Well, basically, it's designed to be repeated. It's something that repeats until a certain condition becomes true or until certain conditions have finally been met. Now, it always starts by checking that condition. If it's true, then we keep repeating. If it's false, we stop. Then we execute the code that's inside of the brackets of the loop. And anything inside those brackets, it can be any code you like. It can be very similar to anything outside of the brackets. It's just another section of code. You could even call functions from inside of a loop. Then you repeat. Go back, check the condition again. Has anything changed? If so, we stop looping. If not, keep going. And I'm going to show you what the syntax looks like, just to not freak you out. It might look a little bit confusing, but I'm going to talk you through it. Once again, you check the condition, you do all the lines of code, and then you return to step one. So if we look at this code, we have basically what's called a while loop, where we have a number of cubes that starts at 0, and while the cubes are not greater than 12, we keep going. And inside the loop, we add 1 to the number of cubes, and then we also display this on our brain screen. So we could pretend that this is actually in taking cubes, perhaps, and showing on the screen that, okay, now I have 1, now I have 2, now I have 3. So let's actually break it down. First of all, step 1 is the condition. The condition, number of cubes, has to be less than 12. And then step 2 is that we go inside the loop. And we execute the code until we get to the end, and we turn back to step 3. And then you check the condition again. And so this is going to repeat 12 times, starting at 0. So that is the basic structure of what's called a while loop. And one of the things that I might say, and you might hear online or look online or look at other tutorials, is people might use the word iterate. Iterate means basically to iterate is to work on something step by step. And so when we say iteration, I might say like first iteration, second iteration. That's referring to like the number of repetitions that the loop has done. And so sometimes someone might say, oh, we need to iterate on this list or iterate on this array until you find this thing, or you need to iterate. Basically, that's what they're saying, is we're repeating. Now, I've shown you a while loop, but there's actually 2 types of loops, and they have separate sets of syntaxes, so let's talk about them both. First, you have for loops, and then you have while loops. For loops, you could think of, let's call for loops Spongebob, and let's call while loops Patrick, just to kind of help us simplify things a bit. So, imagine that we have Spongebob. He's very organized. He has his hamburgers, and he's flipping them. And Patrick, he's very hungry, so he just eats until he's not hungry anymore. And we're going to use that analogy. So with a while loop, you can think of it something like this. While Patrick is hungry, he keeps eating. I hope he stops when he's not hungry anymore. And basically a while loop, you do it while the condition is true, you keep repeating. And so we've already looked at the syntax, but let's look at it again. This is even more simple. I've simplified it completely until it's just the basics. In this case, it's actually going down, because we're imagining that Patrick is eating apples. So you have you start with a number of apples is 6. While the apples is greater than 0, we keep subtracting apples. Oh, and I noticed a syntax error. Oh my goodness. Syntax error right here. We're missing a semicolon. So I'll fix that right now. Okay. How embarrassing. Okay, so number of apples is 6. While n apples is greater than 0, you decrease from the number of apples. Now, if you put this code right into a program, obviously it would happen instantaneously because there's no delay or anything. It would just be done. But actually what's happening is it actually is iterating multiple times, just very, very fast. But let's look at it. So it starts with the while keyword. Like the structure of a while loop, it always says while. Then you write the condition like an if statement, just like if this equals that. So, will not automatically update. You have to change the condition inside the loop. If you don't, or if you don't have something that is going to allow you to change the condition somehow, then actually it's going to never stop. But that allows you to be very flexible. And the thing is that the number of times it loops or it iterates is unclear, because the system doesn't, it relies on you to kind of define that for it. So it can be prone to causing some crashes and freezes. Now, let's look at an example, of a bit more complicated example. This is very simple. What if we have a rule that he can only eat 10 apples, or 10 hamburgers, or whatever? How can we stop him from eating too many? Well, we can use what's called the break keyword. The break allows you to actually exit outside of the while loop while it's still being executed, even though the condition is not true yet. Or even though the condition has not become false, so it would normally keep repeating, you can use break to get out. So let's take a look at that. So for this example, we start by creating, I'm going to zoom in a little bit more so you can see the whole thing. And this one doesn't actually make the robot move, so we're just looking at the code. We start by setting the number of apples here, and then the number of apples that have been eaten is here. And then we print out how many apples there are going to be. If the apples that have been eaten is greater than or equal to 10, then we are actually going to use the break keyword to get out. Otherwise, we keep subtracting from the apples, and we increase the number of apples eaten. And in this case, we are actually causing a delay, so we actually get to watch him eat the apples. So let's do that. So let's run the code. And it should pop up. Number of apples. And it was going very fast, but we now know that it starts at 12. There are 2 apples remaining. Let's run it one more time. Yep, and it works. So it says Patrick is full. He can't eat any more apples. That's this line here. It triggered. And then right after that is break, which then takes us to here. So this is actually right here. This is actually outside of the loop. And then we have the apples remaining here. So that's the basics. Let's go back. So that is how we can get him out of the loop, even though the condition hasn't become false. Now, meanwhile, at the Krusty Krab, we have Spongebob flipping burgers. And for him, it makes more sense to use a for loop. And why? Well, a for loop repeats for a certain number of iterations. You define the repetition criteria at the beginning, and then it'll repeat for that many times. Or you can actually repeat it for each item in a list. You can do that as well. So in this case, we could say for each burger, flip, and then when all the burgers are flipped, he's done. Now, what does it look like? So in this case, we have for int burgers equals 0, burgers less than 6, burgers plus plus. What the heck does that all mean? Well, let's break it down. First of all, we have the for keyword. Then we have 3 statements that are separated by semicolons inside of the brackets. And that actually is what sets up the loop. Then we automatically count up or down, or in a variety of different manners, based on how the condition is. In this case, we're using burgers plus plus, which is shorthand for burgers add 1. It is less flexible because you have to have all these different special syntaxes inside. Okay, let's look at an example. If you want more resources, W3 Schools is actually a really great place for basically a lot of different programming languages, and it's all really accessible, and they even have example code. So they kind of explain how for loops work, and they show different syntax examples. Now this is written in like pure C++, which is a little bit different than what you might use in Robot Mesh Studio or Vex Code or whatever, but it still gives you some cool examples that you can use, and even some fun exercises to practice. So I encourage you to try to take a look at that. And just W3 Schools is great. It has like sections on functions, classes, basic tutorials. It's really handy. Anyway, let's keep going. Oh, here we go. This is what I was looking for. Yeah, so we have the variable so first of all, the first statement, it says the variable will iterate on this thing. Or this is the variable we will iterate with, burgers. And we define it, and we set it as a value of 0. Then you check the condition, is burgers less than 6? If true, we keep going. And this is the operation we apply to the iterator, which is burgers, to keep looping until the condition no longer becomes true. Let's go big again. So basically, in this case, you have burgers equals 0, burgers less than 6, burgers plus plus. That's what it looks like. This is what it means. And then you have this repeating 6 times, first 0 and 0 to 5, basically. So the first burger, then the second burger, all the way to 5, and then we're done. So let's look at some other for loop examples. So here we have setting a start and end number. So here we're actually starting at 2, not 0, and we're going until 7. In this example, we actually count by even numbers. So it goes 0, then 2, then 4, then 6, and so forth. In this one, we count down. So this one's really cool because these for loops are pretty neat because you have so much control of your iteration and how it's going to be counting. But it is very much all about counting. So it's great for things that need to count. And there's actually an example we can take a look at. So let's take a look at that example. I think I already have it loaded here. Let's see. So in this example, we have the first one is 0 to 6, second one is 2 to 7, third one counts up, and fourth one counts backward. Counts up by even, fourth one counts backwards. So let's run it and see what happens. So 0, 1, 2, 3, 4, 5. Yep, 0 to 5. Then 2, 3, 4, 5, 6. So 2 to 6. Counting up by even, 0, 2, 4, 6, 8, 10. Counting backwards, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off! Yeah, well, anyway. So that is the basics of for loops. You can count up, count down, and so on. But the other thing to make note of is the use of less than or equal to instead of less than. So the difference between less than or equal to and less than obviously means that it's inclusive or non-inclusive. So in this case, if you remember, it only counted from 2 to 6. It did not include 7. And this, it counted from 0 to 5. It did not include 6. So in this case, it was from 0 to 10 with including 10 because we had equal to in there. So that's a quick little important thing. Okay, so now let's just quickly do a summary of what we've learned. For loops, they have the for keyword. They have this very special syntax. It's more for counting up or down, and it does it automatically. But it's less flexible because the structure has to be following that particular way. But you can pretty easily predict how many times it's going to loop because of that structure. Now, while loops, on the other hand, it's easier to write them, but they are a little bit more prone to crashing because it's unclear how long it'll repeat. If you're not careful and you don't look closely and write the code correctly, it could actually end up being repeated forever. But it gives you that flexibility. Maybe you want it to repeat forever, or maybe you want to repeat it until a certain sensor detects something and then stop. Well, then that's great for a while loop. It would be not very useful for a for loop. But here, let's talk about that infinite loop. So you do not want to get caught in an infinite loop because it will freeze your code and it can crash your computer. So if your robot suddenly just stops and the code is still running, like it's still, lights are still on, but it's not doing anything, well, it might actually be stuck in a loop, and it's waiting for a condition to become true that never will become true. And so, to avoid that, make sure you use the break keyword and make sure you check your code. Now, if you have something like this, while true, for example, this is a very risky sequence to write. Now, in robot code, you actually end up using this in the driver control period, because the driver control period actually can be an indefinite amount of time, but then the reason why it's safe in the driver control period is because there is a way to disconnect the robot remotely. In a competition, they have a way to just say stop, and that will actually trigger the break keyword on its own. But if you just start writing a whole bunch of these loops inside of your code, that is a risk. So you got to be careful with that. So let's look at some tips here. Basically, try to predict the number of times that it needs to repeat, and that'll help you decide the structure you need. If you know how many times it needs to repeat, then, or you're counting, then a for loop is probably better. Now, if the loop doesn't have to do with counting, or it needs to repeat an indefinite number of times, then a while loop is probably what you want to do. So you go with Patrick if you want that, you go with Spongebob if you know how much you need to count. So let's look at some more examples. Firstly, we have two ways of counting. So we just talked about how while loops and for loops are better for different things. So if you are counting, in this case, here's how you count with a while loop. You have to set the iterator before you go into the loop, and then you add one to the iterator inside the loop. Now, the same code, but make SpongeBob do it instead. You have actually only 3 lines of code inside, and the iterator is defined inside the brackets. This means that SpongeBob can do the same thing with less code. You need 2 less lines of code to execute the same thing. In this case, it's actually slightly different, though. I think this is less than, and this is less than or equal to. Everything else is pretty similar. This is actually counting from 0 to 9. This is counting from 1 to 10, but everything else is the same. And let's look at that example. So let's look at that example in here. That's, I think, this one. Yeah, so this is going to count from 0 to 9. This is going to count from... oh, but then it's going to print it. No, it's looking like it's counting from 1 to 10, but it's actually... Anyway, it'll work. So we run it. It's going to start from... It's going to go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. Yeah. But in order to execute it, it's slightly different. But you get the same behavior. So you can do the same things with both types of loops. It's important to recognize that they both work. It's not like you can't use one or the other. You just got to know how they're working. So I like using for loops for counting because they use less code. Now, what about a loop in a custom function? So this is where we're combining stuff from the last video about functions and the loop code. So in this case, where is the loop? Can you find it? That's right. It's right here. For int x equals 0. I feel like I'm in a kid's video. Like, which way should we go, Blue? Left or right? Did you say left? Yeah. Anyway, yeah, here's the loop, and in here. So here's the function, and here we have the code. Drive and stop, int num. Brain screen print, beginning driving operation. So it's going to say that, and then it's going to go in and start this loop. But how many times does it repeat? Well, it actually repeats based on the parameter that's provided into the loop. So in here, you actually pass in the value, and that controls how much time it repeats. And this code, it just drives and stops a little bit, like kind of, it almost looks like it's stalling out, but it's just kind of driving forward in little increments. So we actually are going to do it 5 times the first time, then we're going to wait for a second, and then do it 10 times the second time. So it should kind of just drive and stop a little bit. So let's see what happens here. So, beginning driving operation. 1, 2, 3. Oh, it kind of stalled a little bit. Let's try it. We'll have to count it again. There, let's try again. Should do 5. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I'm not entirely sure why it only does 3 the first time. It's probably a Robot Mesh Studio error. But, anyway, it should drive and stop 5 times the first time and 10 times the second time. Maybe because I need to give it a little bit of a gap. Oh, it's probably driving while it's... Oh, that's what it is. So let's give it a second. Oh, I have to log in first. That's why. Because it's driving even in the air. So let's take this. There. And now we wait for a second before we start driving. 1 second. 2, 3, 4, 5. There. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done! Excellent. So that is a simple example of combining functions and the looping code we just learned. And we could combine variables. How could we combine variables? Well, I'm glad you asked. Basically, we could also take wait time. So we go int delay equals 1000, and then that is the value we put in here. So now, this is the amount of time that it waits between its executions, which is then controlled from here. And then I can change this to be 2000. And then if I run my code, it's going to pause for a longer amount of time in between its executions. So 1, 2, or let's save them first. Oh no! I have a syntax. What was the error? What? Save failed. I don't know. I don't know, man. Okay, so I think I figured it out, although I wrote the exact same code again and refreshed it. Now it should work. Sometimes you just gotta refresh the page or turn it off and on again, right? Okay, 1, 2, 3, 4, 5. Pauses for 2 seconds now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. So now we can control the delay here, and we can control the drive and stop in a function, and we've combined everything we've learned into one very simple, silly program. And I think that that's it for this. That's all for now. So that gives you the basic information you need to start using all of this information to do coding challenge number 3. All right, thanks for watching.